Hey, what's up everyone? Welcome to the stream. All right, so as usual, let me do a little quick recap of where we're at here. So last week, what did we do? We worked on, we worked on adding support for 4 declarations almost. Just got to do one minor thing for that. But more importantly, and related to that, is support for displaying pointers. What do we call these again? Like kind of like recursively defined types. So like here we have struct node, and in there is a pointer to node. So I had to add special support when parsing this because this is a type that is not fully defined by the time we parse this type in the debug info. So I had to add support for effectively undefined types that get later defined. So what did I call those again? I call those unresolved types. And yeah, it looked like it worked out. In fact, there was something I wanted to try. There's something else I wanted to try related to that, because this is like, you know, a type defined in terms of itself, but it should also work for, like, you know, even if the type is unknown. So for example, let's say I was to do, what would be a good example here? Let's call it like node 2. And in node 2 we have like a node 3, which we can forward declare. So this is also, yeah, I guess I would need support for forward declared types at that point. I almost have it. So this is something we'll be testing. And then it'll be like n3, and then struct node 3 has a pointer of type node 2. So something like this, right? So I'm not saying this is a very good design or anything like that, but the point is that in terms of parsing, if we look at the debug info for this, we'll see it here. So we'll see that first node 2 is defined, and in node 2 it says that it has a pointer. So here it is. So n3 is type 31 is a pointer of type 32, which is not yet defined, and I know that because I can see type 32 is defined here. And is this equals to XS node 3, which is basically a thing that I learned last time, which is like, this is a forward declared type. That's what it looks like. I think what it's saying is X is probably what means forward declared. Maybe it's like a cross reference. I don't know what the X is for, but, and then S means struct. And then and then we have node 3. So it's just telling us, by the way, this type, we don't know what it is, but this is the type. So then later on we would parse node 3, and at this point we now know what type 32 is, and so I would resolve it. So this should work, but the one last thing I got to do is just parse and ignore this bit here for pointers. So that I'm going to start with that, but before I do that, let me at least display that for normal things like node here, everything should work. So let me see here. I'm going to do that, and I'm going to comment this out for now. So let's build this, and we'll start debugging, and you'll see what I mean. Hit F5, so that launches Vectrex, and here we are in the middle of debugging this program. So right off the bat, you can see N3, N2, N1. These are these types here. Let me just make sure they're initialized. So if we look at, hold on a second, right back. Yeah, sorry, it's my air conditioner turned on and I could hear the fan. Anyway, okay, yeah, so what was I saying here? So yeah, if we look at N1, we expand N1. N1 has a value of 1 and points to N2, so we can see that it has value 1. its next points to, now it doesn't say that's N2 of course, but it if we expand it, sorry, next to the pointer, if we expand it, we can, why does it do this again? Star next, is that correct? I'm trying to remember now. Is that how I did pointers? I guess so. Oh yeah, because it's a pointer to a struct. That's right. Okay, so this shows us basically that we've got a pointer to a struct here that we can expand. I probably should like expand it immediately. Anyway, and then you have v2, and then you have the next pointer there, which is of course can be expanded because it's a struct. Yeah, okay, that's it. This is a node star that expands, and we see the node, and then we can dereference that and get these values here. Yeah, it's a little bit weird, I suppose. But anyway, and then of course this next here is equal to 0. Now normally expanding a pointer at 0 should give nothing. It turns out on the Vectrex, because you can actually address 0, unlike on most systems, this will actually like interpret the bytes at whatever is at address 0 and give you values here, but this is all garbage. So I could make the choice of you know, making my debugger not expand if the pointer points to 0, like sort of handle it as a null. I do wonder though if I can do that, because I don't think I can. Because technically speaking, you could lay out data at address 0 that you point to. So yeah, I can't really know. So yeah, I'd have to like just I just have to accept the fact that if you're debugging this, you'll need to know that when you're at 0, you probably don't want to expand it. Okay, so let me just go ahead and implement the support for the forward declared types here. Let's finish that up. So it's going to look like something like this. So let me go back into the RST parser, take a look at, what am I looking for? Oh yeah, the pointer match, LSIM pointer match. So this is the guy right here. So we use that now in a couple of places. And what we got to do, it's very simple actually. I think I just need to add after this equals star pointer, and then we have here some number, and then I'm going to say that optionally, actually I'm not even gonna, should I put in a group? Yeah, I suppose I should. Equals, and I'll just say dot star, and 0 or more of that. I mean, in fact, it should be really 0 or 1 of that. So technically I could say, I think I could go like this. It's a bit unfortunate that in regex you're sort of forced to use grouping even when you don't want a group for this kind of thing. I wish there was like a, I don't think there is, but I wish there was a way to say, you know, I want to create like the two kinds of groups, a named group, like a group that I want to actually extract, and a group that I just want to use for matching, like a matching group, but that I can't extract, if that makes any sense. But let me just see if this works. Oh, and actually I think I lost a closing brace when I did this. Yeah. Like that. Oh, and yeah. Actually, it's all this here. Forward all the way up until this. Because on top of it, there's this comma, this colon at the end. There we go. So this is the group 4 that I need to ignore. All right, well, let's see if this works. In my case, it's going to be the pointer match for the member in bar. So that's going to be this one here. So let's put a breakpoint right there, and let's just see what we get. Let me see, where are we now? Oh yeah, we're in the other file. Okay. So what happened here? My RST parser failed. Let's see. Huh. ID 25. I tried to resolve ID 25. Apparently I did not have that in my set. Why did this happen all of a sudden? So 25 is bar. Let me just double check that this doesn't happen if I don't put in the forward declare here. So maybe there is still a bug with this code, which is possible. Yeah, okay, so I think what just happened is that we are done parsing. So there seems to be a problem with that forward declare line. Let me just see something here. Put a breakpoint at the end of parse. Okay, so we have parsed RST file. Let's see here. Hello. CRT0 followed by foo. Now we're doing foo, okay. And now we just parsed main. Huh. Really? Okay, I see. We would not hit this unless we fail to do the the regular symbol variable match, and right now I only have regular variables. Don't I have node here? So I think what I did is I must have broken the pointer match code. Let me see something. Once again. Okay. So here's forward with A and B. So it's seeing these two. Okay, that's fine. Huh. Why are we here? Oh, okay, it's just the debugger breaking here to evaluate this else, but actually it will not do it. It will actually run. Unexpected match from member. Is that what it just did? I think it's because I'm in release. I can't debug in release. Let's go once again to debug here. I don't know why I'm having these problems, because I have code to disable optimizations for the RST parser. Is that not working? Here. This should disable optimizations, which usually allows me to debug properly in release, but I've been having issues with that. So maybe there's something not working there. It might actually be related to when I upgraded Visual Studio. It's possible that the compiler got updated, and maybe the disabling of optimizations is not enough for it to, like, maybe I need to add some more flags or something for it to behave the way I expect. Okay. Okay. All right, so now we're doing bar. So bar has that pointer in there. So we should forward :27. So bar is the one that has a forward in it. So let's see here. No. Yes. Okay, so we do at least match here. And now we're doing node. Node also has a pointer, so this should work. So the first one is not a pointer. Then the second one is. Okay, so that looks good. And then we're okay. So let's go back here. And yeah, and then we're done with main and we're done. So let's go back and turn on the forward declaration. So in which case forward is not defined. So now we're going to get this case that I'm supposed to capture, and I'm guessing I'm not. It must be that I'm not matching this properly. What? That doesn't make sense. So we've got this struct forward. Actually, how come we're parsing forward first? Given that bar is a struct. Start again. Oh, wait a minute. Am I getting... Is bar not being seen because of this equals excess forward? It's possible. Let me take a look at my struct match. It shouldn't behave that way, but it might. Oh, maybe it's getting confused by this equals here. Although I said equals s, so no, that should be all right. And then I look for numbers, one or more. So s with a number, and then match pretty much everything until a semicolon. So that should match all the way up until here. So that should be okay. Huh. Hey, what's up, Brahim? Thanks for joining. Yeah, I'm totally skipping over this one. Why? Something else has matched it? Oh, that would be crazy. All right, let's try something. What we can do is we can just copy this line right at the very top. This will just allow me to hit it right off the bat, and I can put a breakpoint. I guess in handle stab string match, it's the stab string. So let's do that. What am I looking at here? Oh, okay, foo.rst. Can I, let me do this. Put a breakpoint there and just disable this for now. Okay, so now we're going to parse main. So here we are. So there's our bar. So let's see what happens with this guy. So I just hit the pointer match here. That's weird. So that's not the problem. Then I don't get it. when we're parsing all these types here, it looks like we skipped over this line. Okay. One more time. Gotta love debugging, parsing text files. Okay, so now we're parsing this file. I can see that we've hit the first stabs, which defines main here. That's what we can see down here. So I'm gonna actually just drag that, or not like that, but drag this guy here. Yeah. So that's the string that we're parsing right now. So let me just kind of step through. So we've got the built-in VA list. There's a whole bunch of types we're going to be parsing here. So okay, let me just take this one off. Double, float, complex int, long, all these data types. I'm going to stop at around vtable pointer. Hey, how's it going, Sherpa? SSH, RPA, I'm not sure how to say your name. Sherpa, all right, Sherpa it is. Okay, so there's my vtable pointer. So next should be bar. So let's see what happens. So this is bar. Okay, so I do match it here. Yeah, sorry, Brahim. I know your name is Brahim, but when I see you come online, I just see, Bama Disharef. So I say Bama for short. Oh, hey, Sherpa, thanks for the follow. So risk basically is, yeah, it's like, sorry, what am I saying? Vectrex. You asked me if it was, what kind of, what kind of arch is it? So what kind of architecture? It is a 6809 CPU, which is like a pretty old CPU. I don't know if I guess you could call it RISC. I don't know. I suppose it would be. It's this one here. So I don't know. What would you call this? Does it even qualify as a RISC versus CISC at this point, being such an old processor? I don't know. So it says, unlike contemporary processors that often use a micro-coded architecture, the 6809's internal design was more similar to early simple CPU designs, and to some degree also the RISC machines that appeared in the mid-70s and onwards. So I suppose it's some combination. Doesn't clearly fall into one bucket or another. Right. So it looks like here we correctly identify our type. We don't find the type that we point to, I think. Let me see here. LSIM pointer type. Oh, what is this? That does not look right. So this might be the problem. Yeah, it's pretty reduced for sure. It has a lot of addressing modes, but the instruction set is pretty small. It's one of those, you know, if you look at architectures from the 70s and early 80s, people programmed in assembly language back then. So the assembly languages were mainly targeted at programmers, right? So it was not really about having a huge instruction set. It was mostly about having a very human-friendly instruction set. So somewhere between human and CPU, right? And it was more like by the late 80s, 90s, the programming became more and more higher level in the sense of you used C and C++, and so it became less important to have a user-friendly assembly language. Yeah. So yeah, this is bothering me. This looks kind of complete garbage. What just happened here? LSIM pointer. So let's see what my match base returns here. So I've got this here. This looks fine, I think. Yeah, variable name, that's right. So that's the variable name. So is it? Let's see. Okay, no, wait. This is not right. Okay, this is my okay, yeah, now I see it. I shouldn't be in here. I should be in this. Okay, this is what I was worried about. Okay, by expanding my pointer match, I'm now matching a struct declaration. This is the bug. Okay. See, there we go. So that's not good. Why does this happen? It's because of the colon followed by a number followed by an equals. It's because it's part of the struct thing. So is there a way I can make sure? I mean, one thing I suppose I could do is match structs before I match pointers. That's one way, but because I think this here would not match my struct definition. I suppose I could make this work by saying that, oops, colon in here. Why is that not working? Oh, sorry, I had my function key toggle on. So if I do this, assuming it's always equals some string with a colon at the end, which is what it looks like right now, then this suddenly would not match structs. It would be more specific to pointers. But it might not be a bad idea to try to match the more since a struct has a submatch that is a pointer or a value and all that, it might be dangerous for me, or it might make more sense to try to match structs first in my in my code, like match the ones that encompass other submatches. Yeah, that would make a lot more sense. So I think I'll do both. I think I will go and change my matcher for pointers and add that colon in there. So this now at least should work. So before I change anything else, let's just see that this does what I expect and not crash. Okay, so I'm back to parsing lots of stuff here. So let's go forward. So there's my bar. So this now should no longer match pointers. All right, good. And now it should match struct. So there we go. So now we should be parsing the members of this. So let me see, let's just go for gold and see if it actually works. All right, no crash, good sign. And if I come back into my actual debugger, no? Oh yes, I gotta build it in release, of course. Okay. All right. So that's a good sign. So we wanted to see, so now we've got forward declaration on, and we want to make sure that bar, which is a B here, expands forward, and it does. Awesome. There's forward, which has these values. Our forward is right there. Of course, I didn't set any values in there, but you can see that it has the same values. So here the forward declaration is working. And while we're at it, let's test this new stuff here. So we've got nodes up there. So let's try that. We'll do node 3. Okay, I'll put these in a scope. So let's go like n3, and that has an n2 in it. Let's do an n2 like that, and n3.n2 equals the address of this one, and n2.n3 equals the address of this one. And let's just put like something here, just so that I can put a breakpoint on it. Actually, I think I have to initialize it. Okay. Oh, so maybe broke something, because I see that this usually means this was a crash. So yeah, so it looks like I found another test case here that doesn't parse nicely. So let me block out all of this. Just focus on this one here. Let me see if I can reason about why this wouldn't work. So we've got node 2. So once again, you can see that it's defined in terms of a type it doesn't know yet, which will be type *27. And then that's over here. And then this one does have a pointer of type 25, which should be known by now. So that should be okay. So yeah, I expect this to work, but it clearly is not. Oh, wait a minute. So when I blocked off all the other code, it seemed to have no problem with it. Curious. Okay, so here you can see N3 has a member N2, which is a pointer of type node 2 star. It can expand, and we can see that it points to an N3, which points to the N2, which points to the N3. So there we go. So we've got our recursively defined type here. To help it, obviously it would help if I actually had values in there, but whatever. So why is it that when we bring back, let's start with just the node code here. Does this break it? Okay, so that seems to break it. Let's see. Nothing unreasonable looking. So let's attach and see see where we're crashing. Maybe we'll get some clue here. Wait for debugger to attach. Yes. Attach to Vectrex. Let me disable my breakpoints and just let it, whoops, let it run. Huh. I did not expect that. So let's see, we are parsing line 163. Okay, so we're well past this part. Okay, so it has more to do with my scoping. Interesting. What? So this scope, so this is a scope bug that I apparently have uncovered. 192, what is this? Stab end, this is the close scope. So how does this work again? LB before line 299. Okay, so the scope actually starts here because this is just a declaration. So it is for this last scope that it's seeing. Whoops. And then LB end for, that should be like line 302 maybe. LB04, 305, huh. Interesting. Considers it to go down to here. Fair enough. So what's the problem? Apparently I don't have a current function. Why? So we create a current function. When do I ever clear it, actually? Oh, we move here. I wonder if what's happening Very odd. On the last closing scope, we're done defining the current function. I wonder if somehow, because we have, just like how this seems to be defining itself to get down to here, I'm thinking we're done with our current function. If not current scope, on the last closing scope, we're done defining the current function. Yeah, there's some funky stuff going on here. Maybe I can fix that afterwards. Let's see if I introduce a variable here. Does that change anything? Yeah. So now I don't have that problem anymore. Okay, so I've got some kind of weird scoping bug. It's not the first time I have a problem with main. Okay, let me add that to my to-do list. I'll just put this whole example, but seems to be related to when a scope ends followed by another closing scope. It looks like we're clearing m_current function after processing this. Okay. So I don't want to detract from this thing I'm implementing now. We'll look at that bug later. So I should be able to bring back all of this here without any issue now. Yeah. Put a breakpoints, or just keep going here. So those disappeared. Now we have these guys. Yeah, so you can see at least from the addresses that these are, recursively defined. So cool. So I did want to reorder. Maybe I'll do that as a follow, like immediate next change to this one. I just want to get something committed. Okay, this looks good. Oh yes, I wanted to remove this printf here. Since we no longer declare types not found, so let me go and take a look at that. That's in my RST parser to line 345 or so. If type isn't found, create an unresolved type in its stead. These will be resolved after parsing the entire file. I'll just say these will be resolved later. Once all types. Yeah, that's actually another interesting point. I wonder if, can we guarantee that types that we see will be implemented by the current. I suppose we can't. I was just gonna say, like, I'm trying to think of an example where we would forward declare a type, let's say, and in the translation unit that we're compiling, so a CVP file, that we would never actually see the definition for that type. But I suppose that's okay. By the time we do see one and we call resolve, it will get resolved later, so it should be okay. Okay, so what's the deal with this? I added a function called addType, but I removed this assert because it's... Why did I remove this assert? Right. Because these types don't have a type ID. Let me see. Maybe this doesn't make sense anymore. Oh yeah, here it is. If it's the map, I guess what I meant to say, if it's not in the map, okay, if it's not found, it must be an unresolved type. We will replace it either with another unresolved type or with the actual type. Oh no, wait. Okay, I think I meant send if it's in the map. Yeah, that's what this means. If it's found. So that's the thing. Here I was making sure that when we add a type, that it's not in the map. And then we're about to add it, so we should only add it once. But the fact is that once I have unresolved types, it's possible that we attempt to add it multiple times, which is why I can't put that assert. All right. Okay. So I'll say add support for unresolved types. Forward declared, recursively defined. And what I was saying earlier is we should actually change the order in which we perform these matches here for these types here. Yeah, so let's go like this. We'll put else if here. we'll look for struct first. What just happened here? Okay, that's weird. Oh, it was when I paste, it does some kind of formatting on paste. I don't like that it does that. All right, so let's see, if struct, so we start with struct, then we look for variables, pointers, enums. This won't change anything, but it will ensure that if ever, like, I think it just makes more sense that we should be trying to match the more complex regular expression first, and then after that, especially because structures have parts of it that we will rematch. We can see it here. For each member of the struct, we actually do an LSIM match and an LSIM pointer match. So these two, and in fact, it makes me wonder, actually I haven't tried if a member is itself an enum. Do I need to do something special there? Probably. Maybe not. I think if you declare an enum in a class, the debug info shows it to be outside the class. Like for example, if I did enum something like this, yeah, see how forward types is declared as its own thing? We don't even know that forward types is part of forward, which is a bit unfortunate, really. It means in terms of debugging, I can't like show you forward types as forward : forward types. It's just the debug info doesn't give me that. So it is what it is. So actually, let me put that back in there and say like, yeah, there you go. It knows that FT, it's unknown because it hasn't been set, but it's of type forward types. And all this looks good. This ensures, well, since we match substrings of the struct declarations, it's safer to try to match structs first to ensure we don't accidentally match the struct string as a variable or pointer declaration. Via the variable or pointer matchers. Okay. So now I kind of want to fix this bug. Don't like that it's there. Create a scope and transfer all variable declarations collected so far. Add the first scope to the function. Set the end address for the closing scope. And we go with the parent here. Here, let's make, I think I can easily repro this with a simpler example. There we go. In fact, probably only need one of these. Oh, no. This one worked. Why is that? Okay, so that's interesting. So it really does have to do with adding another scope, I suppose. Let me see if I can reason about this. So we've got main, and I think what I do is create a scope and transfer all variable declarations we've collected so far. So that's how this works. Is let's see here. Yeah, so I guess we're parsing this block here, and while we're doing it, we're saying, okay, we've got a function main, we've got a variable here, and then this is the scopes for that variable, so open and close brace, which in this case are on the same line even, which is only a bit confusing. Can I force this? There. Okay. That'll just make it a bit easier to debug this. So like LBB2 up here is line 317, and LBE2 corresponds to actually the beginning. Oh, maybe that's the problem, that these two share a line. Huh, I wonder if that's the problem. 321 over here. So it's end not inclusive, and that's very interesting. And then after that we have B, and then B is in LBB3, which starts at line 321, and LBE3, which line ends at line 323. Okay. Now let me go back up here. We create a function when we match the function name. So that's when we see this line here. Right? So end fun should be 36. It is. So that's 36 here. So we're matching that. Now we're going to be matching our variable. We set the current scope here. If I had a scope already, I added as a child. I won't be having any of that. But then we're going to come here. So I guess we'll put some breakpoints. There and there. And just one more on the end current function here. Wow, a lot of breakpoints. Delete them all. And we'll switch into debug. Okay, so this is the garbage function that I have in the other file, so don't really care about that. Okay, here's main. So here's our open brace. Let me just put some variables here for watch. I've got this line here. So line 93. That makes sense. So we come here, we create our scope, we transfer our variables, now I've moved them. We only have one, and it should be A. It is. We've got our label here, which is LBB2. So this should find a label here. So find it. It did. And the scope start address. So that label is at address 009A. So that's what we should have gotten here. Obviously it needs to be in hex. So there's our 009A. That looks good. Make current. That's fine. I have no scope yet. I make this the current scope. And it is the functions. Add the first scope to the function. It should have one. Oh, it's empty. I think that's my problem. Yes, that's the problem. The problem is that I don't have an outer. Okay, what's going to happen now is I'm gonna add this, make this the current scope, and I'm gonna make this the function's main scope. And then as soon as the next time we hit the NR brack here, the NR, so the closing brace, which is gonna happen on the next line, we're going to realize that that scope has no parent. And because it has no parent, we're going to say, oh, this must be the last closing scope. So we're done defining the current function, but we're certainly not done. So all we've done is we've opened the scope, we've added A, we've seen this, and we've considered this to be a closing scope. And all of this happens because we don't have scopes for this and this here. We don't have scopes because the compiler says, I don't need this scope. That's why. That's a real shame. This outer scope for main there, it's not useful because there's no variables declared in it. So it doesn't need to create like an extra actual scope for the function. Huh. See, and the difference is as long as I add at least one variable anywhere, you know, inside here and actually set it to something, this now is going to create an outer scope for this variable. You see, now we have 3 scopes. We've got this one here, LBB2, which now starts at line 315. And then the last one, LBE2, ends at line 326. So, and if we don't have this guy, the compiler says, oh, I only have these two subscopes. I don't need a scope for main. So now, how do I know when I'm done defining my function? I was basing it on finding a scope that had no parent, but that is no longer correct. That's a real shame, because it would have been really nice to have a very easy, not easy, but simple and deterministic way to know that we're done parsing a function block. There isn't like a stab line that says, okay, you're done with this function. It's more like, if you happen to be done parsing the file, then you're done with this function, for instance. Or maybe we'd have to look for a non-stab instruction. If we hit a non-stab while we're doing this, it means we're done, maybe. It's not clean. Like if I add a function underneath here, so you see now there's more code added, and then once again there's this. To say everything about this format sucks. See, this is going to complicate things. Being able to determine that I've reached the end on any one of the stab lines really simplifies. But now I can't do that. Looking for a non-stab line to end it kind of sucks. And what I'm thinking is, if I can rely on the next line being a non-stab as a way to know, I don't know if it's a non-stab or if it's a not stab n. It's so annoying. No, see, because there's stab strings here. So what I was thinking is maybe if I have a way to peek the next line. Then I could make decisions based on that. But it's really gross. Is there nothing I can do? Is there nothing clever I could do here? Like, I'm just missing information, I think. I don't know how many scopes there are. And ultimately, I need to create a scope myself if I determine that I'm in this situation, which means that I won't know that until I'm done. And where do I put these scopes for now, right? So like, I have an opening, then I have a closing scope. What do I do? Ideally, I'd like to know even as soon as I start that this is going to be the situation so that I can create this one outer scope myself. Otherwise, I have a storage problem. Let me see here. I suppose I could collect the scopes or something, the root scopes, and then introduce a parent if there's more than one. Ugh. This is complex. Suppose the other way I could do this is always create a scope, and then if it only has one child, I could get rid of that root one. So that gets rid of the problem of having to manage multiple scopes and worrying about the ownership, but it doesn't solve the problem of knowing when I'm done defining my function. Yeah, so this is a bit more difficult than I thought. Probably a terrible idea, but let me take a look at this. I did write a function called getLine, right? So ideally, if I do this, the optimal thing to do, of course, is to cache cache the line that I'm going to return, so that the next time I return that one and parse the next line. So I'd have to just have one initial parse for the first line, and then afterwards, yeah, and then afterwards I would return that one, but parse the next line and return the one we see. And then there's a complication of making sure that we return false when we know that we have no more line. Yeah, that's what I wanted to avoid. Or I guess maybe we could add a function called peak line, which would do the same thing this one does, only as needed. Still not awesome, because we do parse a lot of functions. The other thing I could do is, rather than do this kind of get line thing here, is take the file stream, parse it all, and fill a big array of strings, and you know, our get line, and then just have an index into there. Then we could very easily read any line, actually. So reading the next line wouldn't be so bad at that point. Okay, let's see how this goes. I'll give it a whirl. Okay, and now we say while get line fin I guess I could do end place back. Actually, that won't really matter. Ideally, I should reserve the number of lines. I guess I could maybe figure that out. But anyways. Okay, So we go and we create this RST file, we parse everything, we have this massive vector of strings and memory, lots of heap allocations, which sucks. And then we provide a way to get the next line. I guess it should be called like read line. Wait, return what? Oh, right, I gotta return false if we've got no more lines. Okay. If mCurLine is equal to, or I guess greater than or equal to okay. Okay. I only called the original function getLine because stood getLine. That's the name of the function in the stood namespace. But I prefer read because get gives you the impression that it doesn't advance the stream. I suppose technically I should add a peak line and all that. But right now I don't need it, so let's just do this. Okay, so this is an RST file, so I'm probably going to want to put that in a header at some point. But for now, we'll stick it here. I guess actually I didn't need to put it in here. Okay, whatever. Okay, so here, instead of doing this, well, I guess we do this, and then we say RST file. We construct one from the fin. And then here, instead of calling getLine, we say readLine line, which for some reason it is not seeing. Stood file system path. Oh, okay, I'm reusing this. That's funny. So this should get me at least what I already have. So let's see. We'll build this in release. This will actually be helpful for debugging though. We'll be able to see exactly all the lines and where we're at. So 119 lines, and there you go. These are the lines of our file, so that's pretty good. The last one is 118, and it looks like it's empty. So this is for the CRT0. Yeah, line 118 is empty, so that looks good. foo.rst, that should be a rather short file. Yep. 59 ends, let me just double check this, with a declaration for an enumerator, I guess. Yep. And of course, here's our good friend main. Ends with an else scope 3. Yep. Okay, so we have something. Now, yeah, I will actually want this as a data member so that I can actually do peaks on the next line. So let me do that. And I'm going to need a constructor that does nothing. Okay. Okay, great. So now we can try to go into stab number match and change our code here to not look for the last closing scope, but rather peek the next line, which is such garbage. I don't know if I should do it here though. I mean, it's not always the case that it's going to be on the last stab end, is it? Yeah. The case of a function has nothing. Yeah, that's actually the extreme case right there. Function with no data at all will just be parsed this way, and then we're done. So the question is where to put this. something like this. If we have a function, a current function, it means we are in the process of, this is how we can know, right, that we're building up a function. So as we're parsing directives, if we are currently, parsing a function, we can peek the next line. And I suppose I have to do that after I've done all this, not before. And now if the next line is not a stabs line, so I have a generic stab matcher. So I think that's going to have to be what I use. It's what I use here. As soon as we hit any stab directive, it's going to be the opposite of this. If not, then we're done parsing this function. Or I can say we're done defining. Okay, I mean, I'm going to probably have a function for this, but for now I just want to see. And then there's the other bit to make this work is that I need to add a dummy outer scope every time I create a function. Otherwise, otherwise it's not going to work yet with the current example, because we need an outer scope in this case. So I'll always create one. This is a shared pointer, is it? Yeah. Create a dummy scope in case this function doesn't define one. Or I'll say, always create a root scope in case this function doesn't define one. For example, because the outer scope doesn't declare any variables, or I'll say because the root scope of foo doesn't declare any variables, or doesn't contain, I should say, any variable declarations, the debug info doesn't bother to add scope info. To simplify our parsing, we always create one. Okay, so say we do this. Trying to remember, why is it again that I had to put two of them? And not, what happened when I only had one? That seemed to work. Oh yes, it's because when there's only one, it ends up acting like the scope of foo. Okay, fair enough. So we come here. Now this code will change. Pretty much we're going to always have a scope now. Like this won't make sense anymore. Add the first scope to the function, won't happen. Fact. Yeah, it'll say if I have a current scope. I should have one since I can actually assert this. It's really too bad. I guess it doesn't break anything to put the if for now. Let me just leave it like this. And then over here, all right, whatever, do this. So now if I don't do anything at all, I think what we're going to see is this should work. But I think that when we look at variables in the debugger, we might end up with this extra weird scope. And we're going to have to effectively remove that if we see that a function only has, like, if it only has one root that itself has only one root, we could remove that dummy root node, which should be easy enough to do. If there are more than one, then we leave it alone, because that's this case here. Yeah, complex. So let me just see if this works. Well, first let me make sure it compiles. All right. That is true. That's annoying. Yet another reason why I should move these into their own header file. Okay. What we'll do is we'll just move all of this in here for now, because C++ is annoying. Okay, that compiles. Let's just see if it works. Okay, it's still crashing. So why? What's happening here? Let me hit F5. Probably missed something. Okay, so there's our first. I guess I can remove this breakpoint. And actually, let me put some code into breakpoint, I mean here. Okay, so here I have a function, it's empty. Here we're going to create a scope for it. I wonder if I have to set something in my scope. No, I don't think so. F5, so I have a function. Here we go. Let's peek the next line. So 70 else scope 1. So the current line is 69. What are we looking at here? 69. Wait. Does that make sense? Oh no, I must be parsing another file right now. Hold on a second. We are parsing. No, we are parsing main. Line 69. There are 106 lines. There are 107, 69. So we're here. Oh, okay, yeah, I see. It's very hard to understand this. Okay, there we go. So we are doing this guy, and then we've hit the non-stab. So this is some inline function I have in that header file in dummy. There it is. Okay. Since it has no variables, it has nothing, no scopes. So actually, so let's see here. This is actually the case where we're done defining this function. I actually think I never had this function. So let's say we move that in there. And I guess I technically should be clearing it, but anyway. So here we are about to do function main. Good. We add a scope. And now we are at line 91. Okay, so we should only by the time we're at line 97 should we enter the problem here. So the stab match should fail. Okay. Wait, what just happened? I have a current function, but I don't have a current scope. Did I forget? Oh, I forgot to set current scope. I see. I added a scope to my function, but I never set mCurrent scope to it. That'll do it. So you see here, I even wrote this comment here. Note that mCurrent function may still point to the last one we parsed at this point. This happens if the function has no scopes, no local variables. This is garbage. We don't want that. Hey, what's up, Frosting Fire? All right, so let's see here. Assert, we can put back the assert actually, because we will make sure it's cleared now. So in a way, that I guess this is actually better, because we won't have that weird case of not adding a function that has no variables. How's the tech industry in Montreal? I guess it's all right. Are you looking for a job in Montreal? Actually, Montreal is a pretty good place for tech. We have quite a lot of companies here. Yeah, no, you're right. Montreal is actually more affordable than those places, and we have a pretty good tech industry here. Definitely, if you're interested in games, we have a lot of game companies, and we have a few of the big ones here. You know, Google, we have Facebook, and Microsoft have offices here. So, right. Well, I mean, we don't have only C++ jobs though, right? Okay, so are Google's interviews still algo heavy? Yeah, I would say so. They are still pretty big on the algorithm questions. But one thing they don't do anymore is no more of the cheap shot questions. Like no more of those. What do you call them there? Like those. How many, like, how would you estimate how many gumballs there are in an airplane and all that kind of crap, The kind of tricky, let's see how you think questions that come out of nowhere. They stopped doing that because they found they didn't have any value in, or any predictive value in terms of performance, or, which is great because, I always thought those were bogus anyway. Okay, so what am I doing here? I wanted to check, right. No, exactly, right? Yeah, total. Oh, thanks for the follow. But yeah, like for Google, I actually I did actually study. I actually did study for it. I spent like a good about 5 weeks or so on weeknights because I was working full time. I have a family, so starting at like 9 p.m. till whatever 11:30 midnight, I'd try and do some problems. I used a book. It's called Cracking the Coding Interview. It's kind of like grinding LeetCode, but it's a book, really. You can find it online. There's like PDFs and stuff. Yeah, Cracking the Coding. So it. It's not bad. I didn't do all of it, obviously, because it's crazy. Like so many problems in there. But I tried to like pick. I picked first of all, I picked the chapters I thought were the ones that they might ask about, and also the ones that I felt that I needed practice on. And in there, I tried to pick like a couple of, the way I sort of went with it is I was like, I'll pick a couple of the easy questions, like 1 and 2 or something, 1 and 3. And then I picked, like, say, some of the harder ones for the section, like the last, 1 or 2. And then I just tried to get through them. And that way I sort of like, the easy ones kind of get you into it, and the hard ones can get pretty hairy. But, well, I'll tell you what I think the problems did was they sort of, after a while, and I think if you do LeetCode, you'll see this as well. You get into this groove, your mind sort of gets into this groove, and you start thinking about problems a certain way. And I would say that it did definitely prepare me for my interview. None of the questions they asked were like directly any of the things I studied, but indirectly, sort of in the same vein, or kind of using the same skill set. So I did think it was very valuable. Another thing that was actually really valuable is that I knew that the whole thing would be whiteboard programming, and so I didn't do it on a computer. I did everything on in a notebook, and while I was doing it, I actually was talking out loud, trying to practice the whole whiteboard experience, because we don't do whiteboard programming, right? Programmers don't spend their time at a whiteboard programming, and it's actually a skill. It's not something that comes naturally. Being able to write code with a marker on a whiteboard, and also being able to talk about what you're doing while you're coding, is not a skill that everyone has, right? It turns out that actually what I'm doing here on this stream totally helped me for that. But yeah, not the part of writing. So yeah, there was a systems design portion, which I don't think I actually did very well on, but so they actually don't want you to do pseudocode if you can avoid it. They prefer you pick a language and write something that compiles. In fact, cracking the coding interview talks about that. They have in the first chapter or something, a couple of different sections on the big companies, and they talk about Google, Amazon, Apple, Microsoft, and they talk about that you actually should try to write something that could compile. Yeah. Yes. Yeah. It's not easy, but obviously if you make a tiny mistake or whatever, if you forget something, it's not the end of the world. No one's going to fail you if you forget a semicolon, or even if you use the wrong function name because you happen to forget. As long as if you used, I don't know, count instead of size or something, that's not going to fail you. You know what I mean? That's not the point. But I will say that if you can write code that looks like it should compile and everything looks like it's the right function name and everything, I think that adds some bonus points. You know what I mean? So think of it more like that. It's not going to fail you, but doing it right can garner you some extra bonus points. You know what I mean? So yeah, I think that was my experience anyway. Yeah, and I totally recommend it. And there are many other good resources. That's just the one I happen to use. For me, actually, I've been doing programming for a long time, and in a way, it kind of worked against me, because I feel like a lot of people who come out of university are probably more prepared for the kind of interviews that Google gives, the algo types. And then someone like me with nearly 20 years experience working, I forgot a lot of that stuff because you don't really use it day to day. I don't remember how to implement a heap, and stuff like that, or the sorting algorithms. I don't write those things. So after 20 years of not being in university, you sort of go how do you do that again? So I actually really needed to study. I think some people who come out of university actually spend less time preparing and can still get a job there. So. How would I compare that to the interview process at the non-FAANG companies there? Is that an acronym for the big companies? Trying to put that together there. Non-FANG. Sorry, I don't know what that acronym means, but I'm guessing you mean the big companies, the Apple, the Facebook, Apple, Amazon, Netflix. Oh wow, Netflix made it in there. Good for them. I feel like it should be FAMG. Netflix should be replaced by Microsoft, but maybe that's just me. So how does it compare? Well, it's completely different. Oh yeah, that's interesting. I mean, I'm not surprised that Netflix makes a lot of revenue, but yeah, Microsoft is a big one too. Yeah. So how does it compare? Well, so my experience before that was at game companies. Game companies are quite different, but yeah, it's never big focus on algorithms. It was really like I think like most normal companies, a lot of it is about seeing what you know, asking about your experience, and usually the problems are in the domain. You know, we did tend to use some simple algo problems just to kind of weed out people who really don't know how to program. But yeah, it was never like, it was nothing like what I had to do at Google. The truth is, my own opinion is, I'm not sure how I feel. You know, I don't know about whether or not, like I personally, I prefer the process at regular companies where they just sort of want to see what you know, and then they ask you a lot of questions and you sort of show them. Like I'd rather show what I can do, show projects I've written, talk about it and all that, than spend time writing search algorithms, you know what I mean? Or whatever. But the thing is, at Google and I think all these big companies, the way they explain it is they're trying to find, they have to find like a way to interview many people across the world in as fair a process as possible. And they also have to be able to train many programmers or many developers, whatever, to be able to give those interviews. And so I think that when you try to, when that's your goal, right? When your goal is to create as fair a process as possible, and one that can be taught, you find yourself with a pretty narrow domain in terms of what you can do in an interview. And I think that's where a lot of this comes from. You know, you can ask algorithm questions to a programmer who just came out of university all the way to like super experienced and get something interesting out of that. So a lot of their process is about removing bias, you know, removing any kind of edge that someone might have because of privilege and things like that. There's a lot of focus on that. So so I sort of understand where they're coming from, and I guess I feel like it's sort of the how can I say, like it's sort of the price you have to pay, I guess, you know, for being able to have a process like that. So that's sort of how I see it. Anyway, I hope that was helpful. Yeah, exactly. Because that's one thing. If you want, another thing I can say compared to like when I used to work in game companies, we were certainly not standardized. We did not have a standardized process. You know, like at most companies, I think you'd be at the mercy of whoever was interviewing you. You know, you might get someone who, you know, I don't know, like you might get someone who'd ask super hard questions about stuff you might not know anything about and judge you harshly for it, or you'd get someone else who's, you know, way more generous and didn't ask any of those kinds of questions. And so really, like, it was luck of the draw, and that's not great. You know, in general, you can't really do that in a very large company and make sure it's fair. No, I guess not. Yeah, I agree. But like in a way, it's kind of frustrating, right? Because what it implies, so you see, like there's no perfect solution, right? On the one hand, you know, if you don't like algorithm questions, or you find like they're, you know, whatever, you know, maybe it's not showing off your actual potential, perhaps, you know, because it's so narrow that like what you can show when you do these kind of questions. But anyways, if you don't believe in that, that's true. But like at normal companies, it's really can be frustrating because maybe you're great and you happen to fall on the wrong person to interview you. I hope you get less of that feel at a larger, like at one of these FANG companies. It shouldn't be so much who gets to interview you that changes your outcome. I'm sure that's not true, but let's say they try to remove as much of that effect as possible. Yeah. Even the variable non-FANG interviews are still a lot more skill-based than non-tech jobs. Yeah, it's true. Yeah, definitely. Connections, who you know, what school you went to, like all those things. You're right. All those things, unfortunately, can make the difference. So where do you hail from if you're thinking about moving to Canada? If you don't mind my asking. Oh, okay, cool. So, okay, I think this is supposed to work now. Let me just see what this looks like. So there we are. We were actually able to go in here. Oh, interesting. So it's actually caused no problems having the extra scope there. There are quite a few people that have moved from there already from here, already from here, even some refugees. You're saying to Canada in particular, or did you mean like Montreal? So I was expecting the extra scope to somehow show up here, but I guess my code handles that gracefully. Let me just take a look at what's going on there. To Canada. Well, Canada is a great country. I'm very happy to be here, happy to be Canadian. Oh yeah. Yeah. Honestly, the French is not really a big problem, especially in Montreal. Not homophobic? Are you implying Montreal is homophobic? I never heard that before. Oh, in comparison to there, okay. Oh yeah, eh? Yeah, we're pretty open here. I think. I'll speak for myself anyway, but I think Canada's a very accepting place. So what is it that I want to see? Yes, I wanted to see. Right. Oh, really? Okay, yeah, that's interesting. this is what I wanted to see. I have this function here. Let me do this here. Now if I step, oh, I think I was not attached. That's why this is not working. F6. Let's attach to Vectrex here. Okay, so let me just take a look at this function. So if we expand this, we've got scope. This scope has 2 children. Right, okay, yes. This works because this is the case where there is missing a parent scope, so there's no problem here. Right. What I wanted to see was if I add back like a variable here, so now I'll have like 2 scopes, 2 parent scopes, if you will, a root scope that I added always, and then this one that gets created for the actual function. So this is the case that I want to see what happens when I look at the variables here. So I come in here. Oh, looks okay. Looks okay. That's cool. So let me see now. F6. Put this breakpoint here. Am I attached? No, I'm not attached, I think. All right, so let's take a look again at our function here. The cache hit. Hey, just saw you work at Google. I'm joining Google SF while remotely, I guess, in August. Hey, congrats, man. That's awesome. How was your interview process? Was it grueling? Did you spend a lot of time preparing for it? I was just talking about that. Okay, so I do have a root scope that has just 1 child, and then that one has children with variables. So I guess it doesn't really matter because I just start traversing. Skip scopes that do not contain the current address. And then when I do have variables, I start adding them. So I guess it doesn't really matter the way I wrote this. Okay, you were an intern there 3 times. Okay. So you must have done really well during your internships. So you actually got to skip the interview process, because I suppose you had to do 3 for your 3 internships. That's really great, man. Can I ask you the cache hit? Like, are you far from San Francisco? Because you said you're going to be working there remotely, but what I guess what I'm curious about is, because since everyone's home now and like all companies are, have had to implement work from home policies and all that, it seems like now the market has really opened up, and so people can really apply and work for teams anywhere, as long as they're cool with remote work, which is becoming more and more the norm. So I'm just curious if that played into this for you. Yeah, internships I think count as 2 interviews or something. Oh, I see. So if you do 3, you've done like 6 interviews? Interesting. So this is cool. I think though that I still would like to get rid of the root if it's not necessary. Okay, so you are planning to move to San Francisco anyway. So, and I guess you'll move there and you'll work remotely until things calm down and people can actually go back to an office. I will say I do miss being at the office. There's a lot of also there's a lot of perks, and as you know, if you interned at Google, there's a lot of perks about being at the office, which do not exist when you're stuck at home. The free food definitely is one of them. Yeah. The Cashade was saying that he interned at Google. Oh, no, don't. As I tell most people, do not apologize for interrupting me. This is why I do this, right? If I wanted to program and not be interrupted whatsoever, I wouldn't be streaming. So definitely don't feel bad for asking questions. I'm happy to talk, to answer them, to chat. There's no deadline for what I'm doing here. It's just some fun stuff. So, oh, sorry. So Medis Mailben. Sorry, I don't quite know how to say your name. I'll call you Medis. Did you work on a debugger there? Oh, are you asking the cache hit or are you asking me? Are you asking if I worked on a debugger at Google? So there was something I wanted to see here that kind of baffled me a little bit. It was here. Current function is main. Oh, okay, you're just asking me if I've previously worked on a debugger before. So I have not worked at work on a debugger. I've implemented for my 2 emulators command line debuggers, so sort of in the style of GDB. And what I'm doing here, this is the first time I do this, which is implement this protocol to allow like rich debugging of C, C++ programs. So this is definitely like a bigger debugger thing that I've done, you know? So to answer your question, no, I haven't really worked on a debugger before like this. But I have worked on like command line interface debuggers. So like I said, like GDB. So this project here, like my Vectrex emulator, has a command line debugger and it's great and it does the job. But it was great for like just debugging assembly ROMs, you know, and all that have no C or C++ code. But what I want now is to be able to actually write C, C++ for Vectrex and be able to debug it with the full, you know, breakpoints and variables and watches and all that. Oh yeah, definitely know about LLDB for sure. Yeah, it's the one from you know, on LLVM. Can be used to debug Clang stuff. Yeah, it's good stuff. Do you work like for Google, or because I know Google puts effort into Clang and the whole LLVM thing? Oh, so you're at Google, okay. Oh, Apple, okay. Yeah, nice. Well, I've landed a couple of patches in LLVM, but But yeah, no, haven't really worked on debuggers before, like at this level. So it's really interesting. What am I looking for? Yes, I remember now. So my current function is still main. I'm just waiting because I saw something earlier that bothered me. Here. So this foo here comes from this line. I feel like after parsing this, let me see. Why did peak next line return fail to return something? That doesn't make sense. Yes, I know. As I'm realizing here, definitely is not easy to write a debugger. Oh, I think I have a small error in my code. Because when I read line, current line moves to the next line. So when I do peaks next line, I'm not actually doing the right thing. Oh yeah, so this check is wrong. Because I'm not doing +1. Okay, so that explains the weird thing I saw. Yeah. Right, yes. Objective-C and Swift. Right. How much, I guess I haven't really thought about that too much. Let me see. So yeah, because I know like basically that, you know, LLVM is the back end, and you've got multiple front ends that generate the intermediate representation. So like Clang will compile C++ Objective-C, C++ Objective-C. You've got a Swift compiler, you've got Rust, and a bunch of other front ends that compile to this intermediate representation, and then LLVM can take that and spit out the whatever binaries for the target, or whatever, can spit out even, I suppose, WebAssembly or whatever. But then LLDB, like, is because you know it's got the LL in there. Is it sort of like at the same level? Like LLDB can debug technically anything that the backend can spit out, like that LLVM can spit out. Is that the idea? Because you're saying Objective-C, Swift, and C++, so that's like front end stuff. And I suppose a debugger can't really escape using info from the front end. Like, yeah, like you're saying, there's language level stuff there that's really important. There are certain concepts, I suppose, that are really specific to languages. I haven't thought about that. Yeah, I guess it's sort of a cross, I suppose. LLDB has to be able to I'm guessing LLDB could technically debug anything that LLVM spits out, but in order for it to be a rich debugging experience, some of the info from the front end has to bleed into that, into the debug info. And it has to have some knowledge of what it's debugging, like it's got to know. LLDB embeds LLVM-based compilers. So it actually embeds the front-end compilers. Okay. That's very interesting. Makes sense. And it must be, for sure, much more complicated that way. I suppose it does help, though, that ultimately Swift, Clang, and all these other front ends like Rust and all that, that they produce the same kind of intermediate representation that's needed by LLVM to make it possible. There you go. Okay, right. Yes, okay. It uses the AST for the language. So that's actually specific to every front end then. So I see. So without that, you can debug, but you're not going to get a very rich debugging experience. I'm guessing you'd only even get like what, assembly level debugging without the front end bit? Or I guess you could get some basic source level debugging, right? If you don't have the AST. I don't know. That's a bit beyond me. I haven't really looked at debuggers like GDB or LLDB. It's actually kind of fun writing a debugger without any knowledge of how those things work. So I sort of have to make it up as I go along, Obviously, my use case is really simple compared to what you guys have to do. Like the Vectrex, it's single threaded. I'm actually dealing with maximum C++ 03, which actually turns out to be a lot simpler than having to deal with more advanced stuff. There's no lambdas in there and all that, so I don't even know what that would look like in terms of debug info. Right. I don't have Dwarf. Yeah, PDB for Windows, or like XCOF or something, I think is the actual name of the format. So for me, the reason I even have to write this debugger is because I don't have Dwarf. I'm basically for the Vectrex, which has a 6809 processor. Somebody forked GCC a long time ago, and it's like an old GCC, like 4.6, I think it is, and added the backend for the 6809 CPU. So that explains, first of all, why it only supports C++ 03, and secondly, I guess because it's targeting an embedded system, or I don't know exactly why, but it doesn't really, well, I guess the reason is it doesn't really produce an ELF. It produces like this binary blob that just, sits in ROM, and like you could put it on a cartridge and pop it into the Vectrex and it just starts running like a lot of these older systems. And so because of that, when you enable debug info with -G and compile, you don't get dwarf symbols. You don't get like a binary with dwarf or anything. Instead, you get these listings, and inside the listing is interspersed this information that looks just like this. It's all textual, and it all starts with .stab. So this is called a stabs representation, and this is like a really old debug. I don't know if I can find it here again. I guess stabs debugging. Stabs debug format. Here we go. So you can see like this is from, I don't know how old this is, 1992. So stabs refers to a format for information that describes a program to a debugger. Actually, there's like a Wikipedia for it somewhere. But anyway, the point is it's this text-based debug info. And this is what I need to parse in order to write my debugger. I don't get dwarf, I don't get cough, I don't get something like that. I don't get some nice binary structured data that I can actually use. I have to parse with regex and lots of like unfortunate, guessing of what things mean because there's missing information in there. I have to write my own debug information parser and then extract all this and then use that to implement the debug protocol. So that's basically what I've been working on. Yes, I know that dwarf is standard. But see, dwarf is only standard if your compiler is producing ELF, as far as I understand it, right? Or maybe not. Maybe not. Maybe originally, but anyway. Yeah. Yeah, I mean, it looks verbose. Honestly, it's garbage. There's literally missing information. Like you can see it even here. So for example, this int here, you know, like you can look here and you're like, oh look, some of these types give you ranges. They give you like this long unsigned int tells you that this is the range of values that it can be stored. So you're like, that's cool. And long unsigned int gives you this range. It's 16-bit. But then you have types that don't give you any ranges whatsoever. Here, unsigned int tells you that it's a 8-bit. Unsigned 8-bit goes 0 to 255. But then int, well, int has no range, right? And in fact, most types are defined in terms of int. A lot of these are ranges of int, like float here. But so then, you know, that the problem is that I don't know how large an int is, because you can actually tell the compiler whether you want int to be 8-bit or 16-bit for this target. And you know, that's something like you can see here. This is just some comments, and in there there's an m int 8. Yeah, this argument here tells it treat ints as 8-bit values instead of the default, which would be 16. And I can't figure that out when I parse this line. So there's like a whole bunch of stuff like this that's missing, and you sort of have to guess or ask the user to provide extra information. Yeah, it's not great, but you know, it's an old format, so what can you do? Okay, so here we're about to add food. This is what I wanted to see. So that's actually correct. All right. I'll do this the other way around. Because I can write read line in terms of peak next line here. It'll be time for that. And then the last thing I wanted to do was go to where was it? Curve function. Yeah, so I wanted to like make a function for this. what can I call this? I don't know what to call this. Basically, what am I doing here? If I am in the middle processing a function, we're done defining the function. Because what I want to do is, there's a bit more code I want to add here. Before I move this function into there, I wanted to check if the scope it only has one child. I think that makes sense. Yeah. So this is, you know, replace or like remove the dummy root scope if it's not necessary. It's only necessary for functions that have no variables declared in the function, in the root scope of the function. A bit confusing, but now I'd like to shove all this in a function. So like handle. Yes, I definitely do C++ for a living. Have been doing it for a living for a long time, actually. But yeah, I work at Google on Chrome on a project called Swift Shader. Which actually uses LLVM for JIT. If we're defining a function and the next line is not a stabs line, then wrap it up and add to Yeah, Swift shader. Hey, thanks for the follow, man. So Swift shader here. This one. A few links there, but here you go. This here, or what's a better one? So that's on GitHub. Our official one. Okay, this is the one. This is the official page for it. So you know what I'll do for this is I'll add 2 functions. Thanks, man. Yeah, it's a cool project. I'll make 2 functions. I'll say, you know, start or begin function definition and end function definition. This way I can put the code for these 2 bits that really go together, put those together. Something like this. All right, man. Well, thanks for hanging out. And then the end function definition will do the opposite, which will be our code over here. Here. So you can see the symmetry here. Here we create the dummy, here we remove the dummy. The only difference is, of course, that we do this thing where we actually add it to debug symbols, which is fine. It's good. All right, yeah, I like this. Lots of asserts in there, but that's good. We want to make sure that things make sense. Looking at the time, I'm going to have to stop this stream soon, which is good. We can just continue from here, but yeah, things look good. So, all right, guys, well, I'm pretty happy with this. Looks like that weird crash that we had earlier has now been taken care of. Let me just make sure this works, since I actually put that code in to remove the root scope. Shouldn't be a problem, but just make sure. So first is this case where we need the root scope. Everything looks fine, and then we add this back here. Build. Looks good. That looks good as well. All right, cool. Everything looks fine. So yeah, I'm gonna stop here. I shall be back on Thursday night, same time. So yeah, I guess I'll see you guys next time. Thanks.